So today we're going to talk about congruent triangles. And so if you think about a triangle, triangles have three sides. So a triangle has three sides, 1, 2, 3, and also has three angles. Now, if all three of the corresponding parts of two triangles are congruent, then the triangles are congruent. And what do I mean by congruent? We call congruent triangles, we call those congruent if they're the same shape and size. So long story short, see how angle A equals angle E? Because they have the same symbol. Can you see that? And do you see how angle B equals angle F? Because they both have the two marks. And angle C equals angle G. And AB equals EF. BC equals FG. And AC equals EG. So because all three sides are congruent, and all three angles are congruent, we call these congruent triangles. In other words, they're the exact same size, the exact same angle, everything's exactly the same. Okay, so if I wanted to talk about the triangle, I would say that triangle ABC is congruent. Now here's where it's important. You have to go in the same order. So since I went from A to B to C, when I write this down, I have to start at the same place that would be at A. So I'd start at E, and then F, and then G. So you have to make sure that A and E are in the same space, that B and F are in the same space, and that C and G are in the same space. So that's very important. So what are the corresponding congruent angles? I would say that angle A is congruent to angle E. I'd say that B is congruent to F. And I would say that C is congruent to G. And then what about the corresponding sides? I'd say that AB is congruent to EF. BC is congruent to FG. And AC is congruent to EG. So now we're going to talk about the definition of congruent triangles. And some people call that the CPCTC. And the CPCTC, it just means that corresponding parts of congruent triangles are congruent. Okay, so two triangles are congruent if and only if their corresponding parts are congruent. So if all the sides are congruent to the other sides, and all the angles are congruent to the other angles, then we can use the CPCTC, and we can say that the triangles are congruent. Okay, so sometimes, like, we're going to be doing proofs, and you might see that written as the last line, the CPCTC, and all it says is if you have corresponding parts of the congruent triangles are congruent, then the triangles are also congruent. So I forgot to hit record on here. What we did is we labeled QR as 12, RS as 23, QS of 24, RT of 12, TV of 24, and they said name all of the corresponding angles and sides, and I forgot to put my segment on here. So the first thing we said was that RQ is congruent to RT, and then we said that RS is congruent to RB, and then we said that QS is congruent to TV. And then we also identified that angle R equals angle R, angle Q equals angle T, and angle S equals angle V. And we also said that they don't tell us about the angles, but because we have what we call side, 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 if we know that all the sides of the triangle are congruent to another side of the triangle, then that's enough to show that the triangles are congruent. We call that the side, side, side theorem. Okay, so now when we're naming the triangle, we just have to make sure that Q and T are in the same spot, that S and V are in the same spot, and that R and R are in the same spot. So here's an example that uses what we're talking about. So let's say you have a triangle, WXZ, and that's congruent to STJ. And they want us to name the congruent angles and the congruent sides. So first we'll start with the angles, and we'll say that W is congruent to S. So I'll say angle W is congruent to angle S because they're in the same spot. And then I'll say that X and T are congruent. Angle X is congruent to angle T because they're in the same spot. And then I would say that Z and J are congruent. And I can get that because they tell me the triangles are congruent. Now for the sides, I would say WX is congruent to ST. I would say that XZ is congruent to TJ. And then I would say that WZ is congruent to SJ. So WZ is congruent to SJ.